This is a video of 5.02, section 5.02 for small group. I had to be off the first part of the day on Wednesday, and y'all's class is at 9:15, and so I did have to cancel, but I wanted to go ahead and do the class that I would have done with you and just make a video. So in your email or your announcement, I am going to put in the whiteboard link for you so you can follow along with the whiteboard. I am going to go ahead and skip the do now, and I'm going to talk about this week's assignments. Monday was your 4.10 unit review. It was 5-point bonus. In Class Connect and whole group on Monday, we actually did the 4.10 bonus. So if you missed class on Monday, October the 2nd, you can go back and watch that recording. We actually did the 10 problems that were on that unit, the same exact 10 problems that are on the unit for review, the 4.10. Tuesday, which was yesterday, you had the 4.11 unit test part 1. Part 2 was only for honors. Wednesday, which is today, we're moving into unit 5, 5.02. Tomorrow is 5.03. There is a TGA, but that's for honors only, so y'all don't have to worry about it. And then Friday is 5.04 with an optional bonus there for regular. So I'm going to go ahead and move into example 1. And we are solving equations, so we're going to be using algebra to do that. I have some steps over to the side, over to the right. Let's go ahead and talk about those. When we solve a radical equation, so an equation means you have to have an equal to in your problem, and then a radical is anytime you have this symbol. So that's why these are called radical equations. You're going to, number 1, isolate the radical. Okay. Number 2, you're going to exponentiate to eliminate the isolated radical, and I'll explain what that fancy word means in just a second. You're going to repeat steps 1 and 2 if there are still radicals left in your equation. Number 4, you're going to solve the resulting equation. And then number 5, you're always going to check your answers, because a lot of times we have something called extraneous solutions. When we have a radical in an equation, sometimes our answers do not check back in the original equation. So that's what I wrote as the definition for extraneous. It says values that we get when solving equations that aren't really solutions to the equation. So that's why we always have to make sure that we check our answers back into the original equation. All right, so let's go ahead and get started with example 1. We want to isolate our radical. So I was always taught to put a box around my radical. I want to get this radical all by itself. So that means I have to get rid of the x and the plus 2. The plus 2 is actually being multiplied times my radical. So it's not going to be the first thing I move. It's going to be this positive x. So I'm going to subtract x from both sides. That's going to leave me with 2 times the square root of x plus 1 is equal to, I don't know why I wrote minus 7 when I clearly should have written minus x. So on the right-hand side, we can't actually subtract x from 7, so we're just going to write 7 minus x. We're still trying to isolate this radical. That means get it by itself. It's being multiplied by 2, so we're going to divide both sides by 2. That's going to leave me with x plus the square root of x plus 1 is equal to 7 minus x over 2. All right, so we have done number 1. We've isolated the variable. We've gotten it all by itself on one side of the equation. Step number 2 says we're going to exponentiate. So we're going to look at our radical. Our radical is an understood square root. If it's a square root and I'm going to exponentiate that, that means I'm going to raise it to the power that is equivalent to its index. So since this is a square root, I'm going to raise both sides to the second power. If I would have had a radical that was a cube root, there goes my brain, then I would have raised both sides to the third power. But since that's a square root, then I'm going to square both sides. Whatever you do to one side, you got to do to the other. On the left-hand side, the square root and the square are opposite operations, and they will cancel each other out. So I'm just going to have what's ever left under my radical here. On the right-hand side, we got to do a little algebra. So I'm squaring this, so I do want you to write it down twice. That's going to be the best way to make sure that we do the algebra correctly. This x plus 1 is just going to stay. I'm going to come up here so I have a little bit more room. So I have x plus 1 on the left. On the right-hand side, I'm going to do 7 times 7. This is a binomial times a binomial, so I've got to work this out. 7 times 7 is 49. 7 times negative x is negative 7x. Negative x times 7 is negative 7x. And then negative x times negative x is positive x squared. I multiply my denominators together and I get a 4. I'm going to go ahead and multiply both sides by 4 because I don't want that denominator of 4 to be there. So I'm going to multiply both sides by 4. When I multiply the right-hand side by 4, the 4 in the bottom is going to cancel. So I'm going to get 4 times x is 4x. 4 times 1 is 4. I have 49. A negative 7x and a negative 7x will combine to be negative 14x, and then I have this plus x squared. Now, I'm repeating the steps. I don't have any more radicals left, so I really don't have to worry about number 3, but I am down here at number 4 where it says solve. So I'm trying to solve this equation. It's not a super easy equation, but I do notice that I have an x squared. So if you have an x squared in your equation, you want everything to move over to the side where your x squared is positive. So that means the 4x and the 4 are going to need to move over to the right-hand side. So I'm going to subtract 4x, and I'm going to subtract 4 from both sides. And then that's going to leave me with 0 on the left-hand side. And then I'm going to write my x squared first because I want the highest exponent to come first. Negative 14 and negative 4 are going to combine to be negative 18x. And then 49 minus 4 is going to be positive 45. All right, so I'm left with a trinomial. When we're solving and we have a trinomial, we do want to factor. So 45 is positive. That means my signs are the same. And they're going to be the sign of the middle term. So I know it's going to be minus minus. Only way to get x squared is to do x times x. So factors of 45 are 1 and 45, 3 and 15, 5 and 9. So I usually start with 5 and 9, but I'm seeing this 18 as my middle term. So that's going to make me choose the 3 and the 5. Because I'm going to put the 3 and the 15. So when you put 3 and 15 in, so again, x times x gives you x squared. Negative 3 times negative 15 gives you the positive 45. But then the inside terms will multiply to be negative 3x. The outside terms will multiply to be negative 15x. And that's how you get the negative 18x. All right, guys, we're almost there. Set each factor equal to 0. A lot of algebra in this section. Solve for x. So I don't know yet. Remember, a lot of times our answers don't check when we have radical equations. So I'm getting a positive 3 and I'm getting a positive 15. So I'm going to turn my pen to red and I'm going to check. I'm out of room over on this side, so I'm going to go over here. So my first answer is 3. So into my original equation, I'm going to erase some of this so I can see what my original equation was. I'm going to plug a 3 in for every x. So I have 3 plus 2 times 3 plus 1 equals 7. And then we're going to work it out. So it's going to be 3 plus 2 times the square root of 4 equals 7. This is going to give me 3 plus 2 times the square root of 4, which is 2, equals 7. This is going to give me 3. This is a times. 2 times 2 is 4, and that's going to check because 3 plus 4 is going to give me 7. So I know 3 is a solution. All right, let's check 15. So I'm going to kind of plug it in right here because y'all can tell I'm out of space here. So this is going to be 15. So this is going to be 15 plus 2 times the square root of 15 plus 1, which is going to be 16. And that's going to be equal to 7. That's not going to be true because this is going to be 15 plus 2 times 4. This is going to end up being 15 plus 8, and it's not going to be equal to 7. So that means 15 is what we call an extraneous solution, a solution that we do get from solving but does not check. So what does that mean we do with 15? We throw it out. It's not a true solution. All right, good deal. All right, moving on. I have 4 examples. In number 2, I've got that radical. I want to isolate it, so I'm going to put a box around it. The first thing that I'm going to do to isolate it is I'm going to move this subtracting x. So I'm going to add x to both sides. That's going to leave me with the square root of x squared plus 3x minus 2. I could put 1 plus x, but I actually like the x to come first. That's how most of our problems are set up. So we've isolated the radical. That means we've gotten it by itself. The next step is to exponentiate. We'll change colors there. So since I have a square root, and a lot of your radicals will be square roots, you could see a cube root. And if you have a cube root, then you would cube both sides. But I do have a square root, so I'm going to square both sides. The square is going to cancel out the square root. That's going to leave me with x squared plus 3x minus 2 equals x plus 1 squared. I'm going to ask that you write that down twice. Bring down the left-hand side. Multiply out the right-hand side. So we'll do x times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. We are going to simplify the right-hand side. The left-hand side looks simplified to me. And I do have x squareds, but they're on both sides of the equation. So a cool thing's going to happen here that's going to make this problem a little bit easier. But when you go to try to get your x squareds together, they're actually both going to cancel out. That's going to happen anytime you have the same term on both sides. So that's going to leave me with 3x minus 2 is equal to 2x plus 1. And that just means since my x squared is gone, that I won't have to factor. So I have a 3x on the left and a 2x on the right. 2x is smaller, so I'm going to move that smaller variable over to the larger one. That's going to leave me with x minus 2 on the left and 1 on the right. And then we'll add 2. And that's going to give me an x value of 3. So since my x squareds canceled out, that meant I was only going to solve out to get one solution. And then we do have to check. So we did not have to repeat in this particular problem because my radical went away when I squared the first time. And now we're to the solving step. So let's change to another color. So again, I'm going to erase a little bit of this so we can see the original problem. So I want to know if 3 is a solution. So I'm going to plug 3 in for every single x that I see. So that's going to give me, I'm checking. This is my check step. So it's going to be the square root of, I'm going to do a little bit over here because I think I'm going to run out of room. 3 squared plus 3 times 3 minus 2. So that's going to be 9 plus 9 minus 2. So that's going to be 16 under that square root. Save a little bit of room right there. I would say save the trees, but I'm not writing with a pencil. Minus x, so it's going to be minus 3 is equal to 1. The square root of 16 is 4. We're checking to see if 4 minus 3 is equal to 1, and it is. So that means 3 is my solution. If you had one solution and it ended up not checking and you had to throw it out, then your final answer would be no solution. Sometimes that happens, but since the 3 checked, I did have one solution. All right, let's go ahead and look at example 3. Again, we're following the same process. We're isolating our radical. We're going to do that by subtracting x. That's going to give us 3 times x squared of x minus 2 is equal to 12 minus x. The 3 is being multiplied times that square root. That's why you're going to have to wait to move it until this step. And then these are all basically it's just a lot of algebra. We have our square root isolated, so we've done this step. We're ready to exponentiate both sides. So this is a square root, so we're squaring both sides. The square and the square root will cancel out. That's going to leave me with x minus 2. And then I want to write this down twice to make sure I get it multiplied correctly. A lot of people try to do it without writing it down twice, and that's when I find they make the most mistakes. So let's see what we get. We've got x minus 2 on the left. We've got 12 times 12 is 144. 12 times negative x is negative 12x. Negative x times 12 is negative 12x. Negative x times negative x is positive x squared. And then don't forget your denominators. 3 times 3 is 9. I don't want that 9 in the denominator, so I'm going to go ahead and multiply both sides by 9. My 9s will cancel on the left-hand side. I'm going to get 9x minus 18. I'm going to combine like terms. I'm going to write my x squared first. So I'm going to get x squared minus 24x plus 144. I do have an x squared. It's not going to cancel out. So I'm going to move my 9x and my 18 over to the right-hand side. So I'm going to subtract 9x and I'm going to add 18. And that's going to leave me with 0 on the left. And you do want your equation to be solved for 0 if you have an x squared. And that's going to leave me with x squared minus 33x plus a really big number. I think that's 162. Woo! I have a trinomial on the right-hand side. So I'm going to go ahead and factor it. My 162 is positive. That means my signs are going to be the same, and they're going to be the middle sign. So that's what lets me know this is going to be minus minus. And then I'm going to use x and x. 162 is a really big number, so I had to write all the factors out, and I ended up using 6 and 27 because they're going to add up to be 33, and they're going to also multiply to be 162. So that's why I chose 6 and 27. We'll set each factor equal to 0. We'll get x equals positive 6, and then we'll get x equals 27. But remember, we don't know whether these will check, and so we do have to check them. Okay, I'm not going to show you this checks just because I've done 2 of those, but I will tell you that when we do check, that x equals 6 does check, but x equals 27 does not. I'm just going to put a little x there. So we would have to throw the 27 out. All right, last example. We're going to isolate our variable. We'll start by subtracting 2. That's going to leave us with 3 times x minus 2 is equal to x minus 2. We still have this 3 times our radical, so it's not isolated yet. So we'll divide both sides by 3. That'll give us the square root of x minus 2 is equal to x minus 2 divided by 3. That's our first step. Then we're going to exponentiate. So we have a square root here, so we'll square both sides. The square and the square root will cancel each other out, and we'll be left with x minus 2 on the left. And then remember, we want to write x minus 2 over 3 twice, because we've got to multiply this out. So we'll have x minus 2 is equal to x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is another negative 2x. And negative 2 times negative 2 is positive 4. And then don't forget 3 times 3 is 9. I don't want that 9 there, so I'm going to multiply both sides by 9. I feel like I've already done this problem. This one is similar to 4. So 9 times x is 9x. 9 times negative 2 is negative 18. The 9's cancel. I get x squared minus 4x plus 4. My x squared is on the right-hand side, so I'm going to move the 9x and the 18. It does feel like I've done this one, but once I'm looking at the numbers, I know I haven't. So I get 0 equals x squared minus 13x plus 22. 22 is positive. That means the signs are the same, and they'll both be the middle term. So it's going to be x minus, x minus. I'm looking for two things that multiply to be 22 that combine to be 13. That's going to end up being 2 and 11. You'll set each factor equal to 0. And you'll get x equals 2, and you'll get x equals 11. And both of these actually check. So we didn't have to repeat. We did solve, and now we're checking. So again, I'm not going to show you the check, but you would plug your 2 and your 11 back into this original problem, into wherever you see your x. We're just going to write check. And x equals 2 checks, so 2 is the solution, and x equals 11 checks. All right, hopefully this was helpful. This is the